All right, let me show you something incredible. Our client from Spain runs a fast-growing online clothing store, but they had one major problem. Every time new designer wear arrived, they were forced to do another full photo shoot. Think about that. Paying models, paying photographers, editing costs, studio rentals, scheduling issues, and days, sometimes weeks, of waiting just to upload the new collection. It was burning through more than $18,000 every single photo shoot cycle. But instead of wasting all that money, we built them a custom AI solution, and it cost them only $12,500. Unlimited usage, instant turnaround time, no models, no studios, no headaches. And honestly, they agreed immediately because the value was impossible to ignore. This channel is all about building your own custom apps. Apps for clients, apps for your business, apps for yourself. You don't need coding. You don't need experience. We built everything using Lovable for the front-end dashboards and N8N for automation. So if you want to learn how to create powerful AI tools like this from scratch, make sure you subscribe, because I'm about to show you exactly how it's done.
Before I share with you on how to actually make this application, I will just give you a brief overview about how this application works. So first of all, you will need to upload your model's image, then upload the image in which that model needs to be changed into. And then when you press on generate try on image, the combination of that image will be given out to you. For our backend, we will be using Supabase. We will be storing all the images and all the tables inside of here. And we will also be setting a trigger in here as well to trigger the workflow. Here we will send a post request to this webhook node, which in turn will trigger this workflow on. And then the details will be taken out from the database by the Supabase node here. The image from the model URL will be downloaded and converted into a binary format using these HTTP nodes. And then those two images will be sent to the Gemini. And from Gemini, we will be output the image and as a binary file, and the binary file will be again posted into Supabase and stored in a bucket afterwards. First of all, select the model. I'm using a mannequin in this case, and then I will select a red dress. And when you click on it, after several seconds, you can see the output image has been generated nicely. So we will be using Lovable as our front end, Supabase as our backend, and N8N to automate our workflows. First of all, we will be building the backend side of our application because the backend is what enables us to do all those stuff. Then we will be moving on to building the N8N workflow. And finally, we will be going into Lovable and making the front end there and connecting our backend with the front end. So first of all, something to note is that we will be using Supabase because it is really user-friendly and really beginner-friendly. If you are new to this, you can easily get the hang of this without any kind of coding knowledge. Let's go ahead and create a new project and away you. After you are done naming the project name and database password, go ahead and create the new project. So in order to make the tables in which the data will be stored, we will be going over to the table editor and we will be making 3 tables in here. One table is to store models information. The other table is to store the clothes information. Then the next table will be kind of a combination of the 2 tables, which we will use to generate trigger to our N8N workflow to generate our combination of our images using Gemini. First of all, let's create the table in which the model's information is being stored. All you gotta do is click on this new table, be given the name of the table like so. And now we'll be adding the columns of this table. Each of the models that will be stored in here has a unique ID because this is to differentiate them with each other. If this model has the same file name, it will be a little bit hard for the database to identify which is which. Photo URL will be stored using the inbuilt storage system that is in place in Supabase. Whenever you upload the image into the application, it will store inside a bucket and then it will automatically put the URL of the bucket inside of this row. And now the models table is done. Now, as you can see, I have gone ahead and created the rest of the tables as well. In the clothes table also, like last time, you have the ID name and photo URL. And in the model clothes request table, I have model ID linked to this models table, clothes ID linked to this clothes table, and the model URL and the clothes URL respectively in here as well. And also I have a column called request. Whenever you click on the generate button in the Lovable interface, this will be changed to pending. According to this request, only the edit and workflow will be triggered. And when you click on request, the model URL, a clothes URL will be sent into here with the model's ID and the clothes ID as well. And one thing to note down is that whenever you are creating the table, make sure to have the ID as unique universal ID, because whenever you add entry into this table, it will automatically generate a random UID for it, which is unique to that row only, and make sure to have this as primary as well. Now we have finished working on the tables, and now let's head on to the next section. Now that we have done creating our tables, the next session is setting up the storage part. So this is actually where the images will be stored when you submit your model's image, the clothes image, and where final generated image will be stored. So all you have to do is, first of all, create a bucket for each of the images. I have finished creating all the 3 buckets. The reason we are making separate buckets for each of these images is because there is a chance that it will call a model's image or a clothes image instead of the generated image. So that is why we are storing each of these images in separate buckets. Now that we have created it, let's set up a trigger to actually trigger the N8N workflow inside Supabase. So we went ahead and made the trigger for this here. Because this is a really specific thing and I need to call N8N, you won't be able to create it from here since this is not a basic trigger. So I went ahead and generated SQL query for this using ChatGPT. You can do this as well. You just need to specify what kind of trigger you are making this for, and table names, which I will be explaining here. Whatever the request, like we discussed it in the model clothes request table, whenever this request column changes to pending, it will send a post request to this N8N post URL. I will show you how to copy this when I'm explaining the workflow. If you want to make this trigger yourself, all you have to do is just copy and paste this as it is working. And when you run this, it will say the success no rows returned. Head on to the database section and click on the trigger section. Your trigger will be created. Now that we have created the backend before connecting it with the front end, let's head on to making our workflow. First of all, you will need a webhook trigger node. Like I explained before, we will be sending a post request in N8N. So that post request will trigger this node. All you got to do is just see that post from here, no authentication, and make sure to copy this production URL and that you just copied into here. After you have pasted it into here, now your database and your N8N workflow is properly connected, and we can continue with the rest of the workflow. Now you need a Supabase node to get the data directly from your database. You will select get a row node, and now you need to make sure that your Supabase account is properly connected into here. And if your credentials are properly connected, you will be able to see tables in your workspace, tables in your database. So from here, click on the module close request table, and now I need to select a condition for this as well. A condition is request will be pending. This time, using this Supabase node, we will actually be pulling the data related to that pending request. Now everything is done. All you had to do is connect these two. And now let's head on to the next part of our nodes. Next nodes will be 2 HTTP nodes. Just like I explained before, in the model clothes request table, we have 2 columns called the clothes URL and model URL. So we need to get those URLs separately so we can combine them at the end using Gemini. So that I will be adding 2 HTTP nodes here. You can do that by just clicking on HTTP request. For your own convenience, you can rename this so you do not mess this up. Rename it to clothes for now, and this one to model. For now, let's keep it like this. And now afterwards, you need to add a Gemini node in here. This Gemini node will be the one that will be combining both of these images. Go ahead and click on generate an image. Gemini will be the one that is combining these 2 nodes and producing an output. Gemini node will be the one that will be taking those binary data and combining both of those images. So that's clear. Search Google Gemini and click on edit an image. Make sure, like Supabase, make sure that your credentials are properly backed. The prompt is actually really important in here because this is what will tell Gemini what to do. They already have a prompt here that I have prepared for this instance. You need to properly mention what image should go on top of the other image. In our case, we will be tracing our model with that image. You need to be really accurate about everything, or otherwise even the background can be changed because of this. Since there will be 2 images coming into this Gemini node, you will have to have 2 of these binary field name nodes in here. And when everything is done, you will have to make sure that this is connected as well. Out that you have generated an image using Gemini. Gemini outputs binary type of file. Now you need to send it back to Superbase, right? For that as well, you will need to use HTTP request node and use the post method. First of all, you need to select authentication and select predefined credential type. And from here, select Superbase API. And since you already gave your proper credentials, it will be listed here. And now as the URL, what you had to do is copy whatever the project URL you gave here. This is your project URL. Copy it, paste it over here, and then type in the following things here. And at the end, you need to specify the bucket name. So in our case, it is final_image. That's all for setting up this workflow. Now I will talk about the prompt that made this app happen. Something to note is that you need to be really specific when you are making the prompt. And also there is a Lovable documentation as well when it comes to prompting. I have read it and adhered to every one of their guidelines, and I'm making this application because otherwise you will not get what you want. First of all, I specified that I am only building the front end, do not create any kind of a backend on our cloud or any kind of a custom inside Superbase. I have specified that I have already created one and now we should connect it to that. And you say it like this, you will be prompted inside the chat itself, allow you to connect your Superbase account into it, and then you will select your project from there onwards. So then for the page layout, I said I just need a sync between UI with this section. As you saw before, the model upload section, the cloud upload section, and generate button. I have also specified that so an immediate preview of the image I have uploaded. And now let's go to the backend. Something I need to highlight, because I started doing the application from the backend course. Now I have a clear idea about how my application works, and now I have a clear idea about how the AI should connect my application. Because of that, now I'm able to give specific instruction to Lovable as well, get my job done easily without any kind of hassle. When we go to the backend interaction part, I have specified that I have some buckets where the images should be uploaded when the generate button is clicked. I also specified the column names inside each table while specifying what table it is. These things, although seems kind of a hassle to you at first, you need to do these things because otherwise you do not know what AI can do when it's doing the job on its own. And I also specified about interaction with NACAN. As you can see, I have set that the NACAN will upload the generated image into a bucket in Superbase, and that the URL of that image should be updated inside the model cloud's request table, and to create the result to show the generated image as well. So technical requirements, you can ignore this if you want, but since we are building this for our client, we needed to specify them because they had some certain requirements from us that these technical requirements should be inserted inside the application. So we went ahead with those instructions as per our client, and finally I give proper preview about what the final expected output looks like. It's easier for the AI to build it according to that. Make sure to give your prompt right from the start by being very specific and on each of the details you are giving. Otherwise, you will not get the expected output you want.